So one more discussion that we need to have is how do we find the derivative of a function raised to a function? All right, so f of x raised to the g of x. All right, a function raised to a function. And let's say this. A function of x raised to a function of x needs logarithmic differentiation. All right, so that's how we're going to handle these, with logarithmic differentiation. So an example of what this would look like is something like this. Y equals x, right? So instead of x to a constant like x cubed, which we're used to finding the derivative of, we get something like x to the sine x. All right, a function of x raised to another function of x. So anytime we're using logarithmic differentiation, this isn't too different than the examples we've done so far. We take the natural log of both sides, and then we have these wonderful laws that work with the natural log function where I can take that exponent and drop that in the front. All right, so now I have sine x times natural log of x. Now I'm ready to actually start taking the derivative. So notice so far I've only been rewriting the equation. I have not started to take the derivative yet. So now when I take the derivative of both sides, on the left-hand side, I get 1 over y times the derivative of y, which is y prime. And then over here, I need to use my product rule to find that derivative. So derivative of the first, derivative of sine is cosine, times the second unchanged, plus the first unchanged, times the derivative of the second. And again, I want to solve for y prime. So on the left-hand side, I have y prime divided by y. So if I multiply both sides by y, right, so if I multiply all of that by y, then I get y prime alone. And I don't want both x's and y's in my final answer, so then I ask myself, well, what does y equal in terms of x? All right, and in terms of x, y is equal to x to the sine x, right? And then I've got this whole expression here on the inside. And again, these final answers really aren't going to look very pretty. I wouldn't suggest trying to do anything more in the way of simplifying here.